Today we're on page 2 of the Chapter 13-14 Chem 1 packet, and we're going to be talking about the heating curve of water. You'll recall from your first lab that we took some water in a test tube, and this graph kind of went backwards where you froze the water, and then it stayed at the same temperature while it was freezing, and then it went colder as ice. Then you took that ice and you set it in the air, and then it warmed up, and then it melted, and then it went back up in temperature. So this is what we call a heating curve when we go from left to right in this graph. So we're heating as we go this way and then cooling as we go the other way. So if you had ice coming out of your freezer, it would be colder than 0 degrees, which is the freezing point of water. So you would pull it out of your freezer, try this at home, put an ice cube on the counter and look at it. It's not going to melt right away. It's going to first increase in temperature, which of course you're not going to be able to see, but then when it starts melting, you know it has hit 0 and it's melting. And then once it hits all water, it's going to warm up to the temperature of your kitchen. But if you kept heating it, of course you know it would heat up until it went to boiling. Once it boiled at 100, it would stay at 100 until the whole thing turned into steam. So boiling water will stay at 100. No matter if you turn up your stove or heat it up hotter in temperature below, it's still going to stay at 100, but it'll just evaporate faster. And if you could catch all the steam, then the steam itself would go up in temperature. So water at normal sea level can only be 100 degrees at most, but steam will be hotter than 100. Okay, so now we're going to try to figure out how to calculate the amount of heat required to do this heating up. Okay, so what we're going to do is we're going to look at these different values which are called specific heats. So if we look at this one, the first one is 2.0 joules per gram degrees Celsius. So we're going to point to this. 2.0 joules per gram degree Celsius is how much heat it takes to warm up ice. Okay, then we're going to take the next one, which is 334 joules per gram. 334 joules per gram is how much heat it takes to melt 1 gram of ice. This 2.0 joules per gram degree Celsius was how much heat it takes to heat up 1 gram of ice by 1 degree. That's for this part right here. The 334 is for this part right here to melt the ice. Then you're going to heat up water. It takes 4.18 joules per gram degree Celsius to heat up water. And then once you're up here and you're evaporating, that takes 2260 joules per gram to evaporate or boil. And lastly, 2.1 joules per gram degree Celsius to heat up steam. So let's take a quick example. Let's suppose that we were going to take a 10-gram ice cube. So you have a 10-gram ice cube right here. You pull this out of your freezer, and let's say that this is at -5 degrees Celsius. Okay, from your freezer, and you want to heat this up, and you want to heat it up all the way to room temperature sitting on your counter, which is, let's say, 25.0 degrees Celsius. The key to doing these problems is to figure out in which zone you start and in which zone you end. So I'm going to call this zone 1, zone 2, zone 3, zone 4, zone 5. So we're starting in zone 1 because we're at -5. We're starting right here. Okay, so I'm going to put a little mark right here. This is where we're starting. Now, what's going to happen to this ice cube? The first thing it's going to do is it's going to heat up until it gets to 0. The next stage is zone 2, where the ice cube is melting on your counter. Then the next stage is zone 3, where the ice cube heats up to about 25 degrees Celsius, which is going to be roughly over here. So you'll see that this problem has 3 zones, 3 areas that we're going to go through. This is the heating ice, the melting ice, and the heating water. So this is 3 problems in one. Whenever you're in zone 1 or 3 or 5, the equation is Q, which is heat, equals mc delta T. So Q is heat, M is mass, C is the specific heat or heat of fusion or heat of vaporization. Any of these values right here are the C values. And then delta T is the change in temperature. You'll see that delta T is in zone 5, zone 3, and zone 1 because the temperature is changing. But you'll notice that in zone 2 there is no delta T because this temperature is staying the same. And you'll notice that in zone 4 there's no delta T because the temperature is staying the same. So let's try this. We're going to start with this part of the diagram right here, zone 1. Zone 1 is MC delta T. So we're going to write that down. We're going to write Q. I'll write up here for zone 1. Q M C delta T. Now for zone 1, we know that the M is 10 grams. That's how much the ice cube has a mass. And then we're going to copy down this C value right here. 2.0 joules of energy are needed to heat up 1 gram of ice cube by 1 degree Celsius. Now the delta T only for this zone, okay, only for that zone, is going to be 5 degrees because it went from -5 to 0. So that's, you just do absolute value for delta T. So now you're just going to take 10 times 5 times 2, which is going to be 100. So this is 100 joules. So that's how much energy it took to make the ice cube go from -5 out of your freezer to 0 on your counter. Now the ice cube is going to start to melt. When it melts, you're just going to use Q equals M, and this is delta H fusion, heat of fusion, which is going to be right here. The heat of fusion of ice is 334 joules per gram. So we're going to use this. But we're just using Q equals MC. There's no delta T because we're not changing temperature. So the C value is 334 joules per gram. The mass of the ice cube while it's melting is still going to be 10 grams. So quick math tells you this is going to be 3340 joules. That's how much heat it took to travel on zone 2 from melting the ice. Lastly, so that was this part from here to here was zone 2. Now we're going to go to zone 3. We'll pick a different color. So we'll go from here to here. That's going to be zone 3. And we're using this as our C value. And remember that this is going to be MC delta T. So Q equals MC delta T. The mass is still 10 grams. The C is still 4.18 joules per gram degree Celsius. And the delta T for this zone is right here from 0 to 25, so that's a 25 degree difference. Okay, and this should be 0.0 with 3 sigfigs. And then you're going to do the math for this, and you're going to get 1,045 as your answer. 1,045 joules, that's the Q for just zone 3. And now all you have to do is add this all up. So 1045 plus 3340 plus 100 gives you 4485 as your total. So 4485 is your total. I'll just write that over here. 4485 joules is your total. And this is how much heat it took to take an ice cube from -5 degrees Celsius all the way up to 25 degrees Celsius. And this is what the next worksheet is about, which I'll show you a couple of quick examples on that. Now we'll do a few examples from worksheet 16 in the chapter 13-14 Chem 1 packet. And let's recall our map. Our map of heating curve of water. Remember, 0 is where ice melts, 100 is where water boils, and you're going to have a diagram that looks something like this. So remember that you have 5 zones. Let me just fix this real quick. You have 5 zones here, and you're going to figure out in which zone you are for each problem. That's really half the battle right there. Okay, so we'll try to check it out in each problem. So here's a quick sketch of that drawing, 5 zones. And look at what this says. How much heat energy is needed to melt a 25 gram ice cube, which is at 0 degrees? So if the ice cube is already at 0, you're starting here, and you want to melt it, it's going to end there because all you're doing is melting it. That's just zone 2. So remember, zone 2 is Q equals MC, and then all you're going to do is copy down the C value from the other page for the heat of fusion of ice. Okay, let's try to look at the next one. The next one we'll do over here. Here's a quick sketch. And it says how much heat energy is needed to evaporate 40 grams of water at 100 degrees. So it's at 100. This is already at 100. Water at 100 is here, and you want to evaporate it, so you're just going to there. So this is, again, just a one-step problem and it's zone 4, and zone 4 is just Q equals MC. Okay, let's move on to C down below here. How much heat is required to change a 50 gram ice cube at -4 degrees Celsius to 24? So now we have several zones that we're going to look at. So here's the quick sketch of our map. And if we're starting at -4, we're going to start, let's say, over here. And if we're ending at 24, let's say that we're going to end over here. So this is going to be 3 steps. Okay? The first step is zone 1, where the ice cube has to heat up. That's going to be a Q equals MC delta T. Okay, that's zone 1. But then, once it gets to zone 2, it's going to melt from here to here. So that's going to be a Q equals MC. And then, it's going to heat up the water. So this is going to be a Q equals MC delta T. Let me remind you that this delta T is only for zone 3, right there. That's the delta T for this calculation. And for this delta T right here, in blue, you want to make sure that you're only doing the delta T for that zone. You're not going to simply take the difference between -4 degrees and 24. That's not the delta T. The delta T is just for the zone you're in. So for zone 1, you're going from -4 to 0. That's that delta T. There's no delta T for zone 2. And then zone 3, the delta T is only from 0 to 24 degrees Celsius. Okay, let me help you out a little bit more down here. If you're good, go ahead and do the worksheet. If you need a little more coaching, I'll keep going here. So we're going to make a diagram for this number 5. And number 5 is this drawing. And it says you're taking 100 grams of water at 80 degrees. So 80 degrees is like over here. And you're going to steam at 100. So this is important that you see this says steam at 100, because steam is on this side. This is gas, this is liquid, and this is solid. Okay, so steam at 100 is going to be right there. So this is going to be a 2-part problem. The first part is going to be zone 3. So zone 3 is going to be Q equals MC delta T. That's zone 3. And then zone 4 is just going to be Q equals MC. Then you put in your numbers and then add up the Q's. Next drawing, here's a quick sketch. And we're going to change ice at 0, so remember ice at 0 is over here, to water at 60, which is going to be over here. So this is a 2-part problem. The first, oops, all right, so that's the zone 3 and this is zone 2. So the first one is going to be zone 2, Q equals MC. But then zone 3 is going to be Q equals MC delta T. And then you're going to add up those 2 Q values. Lastly, number 7, move this up a little bit, do a quick sketch. Here's the quick sketch of the map. Okay, how much heat is required to raise the temperature of 80 grams of water from 25 to 75 degrees Celsius? So water at 25 is simply going to be right there in zone 3, and water at 75 is also going to be at zone 3. So this is just a 1-step problem in zone 3. Q equals MC delta T. And remember, the delta T is the difference between these 2 temperatures, and then you find your C value on the last page, and then you find your Q when you're all done.